Hello, this is lesson 8.1 for honors, one-step equations, and actually in your textbook it's called equations with rational coefficients, which we will get to on the bottom right here, but I felt like we needed to introduce one-step equations first, and then we can work our way to rational coefficients. So what we're going to do is we're going to look at the top left box. And you need to have two colors with you. A pencil and a red pen is fine. Also, if you don't have this handout, you can download it on the same page that you found this video on PowerSchool. Okay, so let's go ahead and take a look at the first property, which is the subtraction property of equality. And what that says is what you subtract to one side of an equation, you must subtract to the other side of the equation. Okay, so this property is used when it's an addition problem shown, like this one here, and we're trying to get x by itself. Okay, and I know that right now it might seem, well, you can do it a different way, but for now I want you to do it this way, so when it gets to the more difficult problems, this will be a piece of cake. Okay, so I want you to circle the variable and draw your line underneath the equal sign. All right, so underneath what this does when you're circling the variable is it shows you what you're trying to get rid of. So in this case, I want x by itself. Okay, my whole goal is to get this by itself. It's called isolating the variable. So we want to get rid of that plus 18. Well, we have to do the inverse of what plus 18 would be. So that way it becomes a 0. So underneath that plus 18, I want you to write minus 18. Okay, because plus 18 and minus 18, those will zero out. And now we have to do it to the other side. Okay, now the reason why is because it's an equation and you want to make both sides remain equal. All right, now we're going to draw our total bar. Okay, and by the way, this part here is showing that property being used. Okay, so now we're going to draw the total bar, and that plus 18, that minus 18, like I said before, is going to be 0. We can cross them out. And if you want, you can write a 0 here. So now this says x plus 0. Okay, x plus 0. So what I'm going to do is on the bottom, put what I have on the left side, which is just the x. And then that equal sign is going to fall straight down that line. Okay, and then on the other side, we have this problem that we have to simplify. Okay, so I'm going to add a 0.0 to the end of that negative 18, negative 18.0. Okay, and remember, when it's subtraction, we can do keep, change, or what I tell kids at this point, both of these now you'll know that they're negatives. This is a negative, and that minus sign, that subtraction, is going to make this also a negative. So these are actually the same signs. So we're going to add them and keep the sign. So the subtraction in front kind of acts like a negative sign. So we're going to add them, and we're going to have 4, and then the decimal point goes straight down, and then we'll have a negative 30. So x equals negative 30.4. Okay, on problem number 2 now, what we're going to do to save time on the video is we're going to save this problem and we're going to do it together as a class the next time we go, when we get to go over this in class. So we're going to leave this blank for now, and I'm just going to put a little note that we're going to do it in class. Okay, so there it is. You don't have to write do in class. We'll just do it together when I see you next. Okay, so now let's take a look at the right side of your notes, the upper right. And on this part, this is called the addition property of equality. And we use this property when we have subtraction equations. So the property says what you add to one side of an equation, you must add to the other side of the equation. Okay, so here's our equation. Our whole point is to get x by itself. So again, I want you to, with your red pen, circle the variable and draw your line. Okay. So now what this shows us is we're trying to get x by itself, and we want to get rid of that minus 3.25. So you've got to do the inverse of subtracting 3.25, and that inverse is to add 3.25. So I'm going to go ahead and write that underneath that. Okay, and then do it on the other side. Add 3.25. You have to do it to both sides to make that equation still equal. The left side and equal to the right side. So now, on the right side, the minus 3.5 and the plus 3.5, they're inverses of each other, so they're just going to zero out. You can write a 0 on top. Sometimes I don't even write the 0 on top. I just know it's going to be 0. So I'm going to just bring down the x. Okay, the equal sign is going to fall down. And then on the left side, we have to simplify this expression. So we have a negative and we have a positive, and we're adding. But when we're adding, we're actually subtracting. Okay, so I've got to put a 0 here. All right, and so here, I know it's going to be hard for me to borrow with this big pen. All right, so now when we subtract, we're going to get 5, 0, and then 2, and then a 1, and then it's going to be negative because the greater absolute value is negative. So this is my solution. Negative 12.05 equals x. Okay? Okay, so now for the second problem, again, we're going to do this one also in class to save time on this video. So don't do it now, save it for the next time I see you. Okay, so now we're on the bottom left of our notes, and this is the division property of equality, and you could have probably figured out what we're going to write here, but it says here what you divide to one side of an equation, you must divide to the other side. So these are used for multiplication equations. Okay, so over here is our negative 0.8y is equal to 56.16. This is a multiplication problem, and we're going to use division to help us isolate the variable. So we're going to circle y, okay, and then underneath the equal sign, you're going to draw your line. Okay, so the inverse of multiplying is dividing. Okay, this is multiplied, so we want to divide it so that way this coefficient is going to be 1y. Okay, we want y all by itself, and when y is by itself, it's actually 1y. All right, so here I'm going to divide, okay, by negative 0.8. Okay, I'm not going to add 0.8. I'm dividing because this is a multiplication problem. It's not a subtraction. And then again, you have to do it to the other side. Divide by negative 0.8. Okay, so now you're going to bring down, you don't draw a total bar on this one because that would be too many bars, but the negative 0.8 and the negative 0.8 divided by itself is going to be 1y, which is what we wanted. Okay, the equal sign falls straight down, and then 56.16 divided by 0.8 we have to solve. So on this side, you'll notice that I'm already starting to do the problem, the division part. I'm just going to move the decimal point on the outside number to make it a whole number, and then bring the decimal point up, and then you're going to divide. 8 goes into 56 7 times. You get 56. You subtract. You get 0, but then you bring down the 1. 8 goes into 1 0 times. Okay, and then you can bring down the 6. 8 goes into 16 2 times. Okay, so then it's a positive divided by a negative, so it's negative 70.2. Okay, and then we box our answer. Okay, so again for problem 2, we're going to save that for class time, so leave that blank for now. Okay, so now we're on the bottom right of the notes. It says what you multiply to one side of an equation, you must multiply to the other side of the equation. That's the multiplication property of equality. So these are the rational coefficients. Remember, a coefficient is just a number that's in front of the variable being multiplied to the variable. So the rational coefficients is just a number that's going to be either a fraction or something that can be written as a fraction. Okay, so this is our rational coefficient. So anyways, that's just vocabulary there. We're going to get x by itself. That's what we want. We want to isolate that variable. So we're going to circle x. Okay, we're going to draw a line underneath the equal sign. And a lot of kids, when they see this, they're like, wait a second, this is times. So why on a times would we, are we going, how are we going to, don't we just divide by negative 1/2? Why would we multiply? But remember, I mean, you could divide by negative 1/2, but remember that when you are dividing with fractions, it's keep, change, flip. So we could actually multiply this by the reciprocal, okay? So if I do that, okay, first I can make that negative go on top, okay, and then if I times it by a negative 2/1, and on this side I'm going to just put, I'm not going to put it as a as a fraction. I'm just going to write here -2. Okay, so I'm just writing that -2 in parentheses. So anyways, on the right side, notice that these two, the 2's are going to cancel out and they'll become 1's, and the 1's are already 1's, and the negative and negative will be a +1. These two multiplied together will be a +1. So we can cross cancel the -2 and the 2, make this a 1 and a -1, and this will be a 1x in the end. So this will just be x. The equal sign falls down, and on this side it's just -2 times 7, which is -14. And so there's our solution. -14 equals x. Now let's take a look at problem 2. Problem 2, we're going to circle the variable. Okay, so now we have two fractions, and it really helps to circle the variable on these because then you can really see which fraction we're going to try to get rid of. So here we're going to try to get rid of that 6/7. That's the coefficient. Okay, so to do that is we can either divide by 6/7 or just simply multiply it by its reciprocal, because that'll give us 1x. So you do that on this side, multiply it to both sides. On the first fraction here, the 3/14, that -3/14, put the negative at the top. Okay, so the 7/6 and times 6/7, those are going to cancel out. Okay, it's all going to be 1's. So I'm going to have an x all by itself. The equal sign falls down, and on this side, I'm going to cross cancel. This will be a 1, this will be a 2, divide by 3 here, -1, 2, so that's -1/4. Okay, and that's our solution to problem 2. And then we're going to leave number 3 for in class. So I'm going to write just a little note so that way you know. So when I see you, we're going to work on these problems that we didn't get to. Okay? So that's all for your notes. Thank you very much. Bye-bye.